Okay. What is another word for translation? The everyday word. Slide. Now, I was talking to Mrs. McCurdy the other day in the hallway, and she was telling me how she remembers these things, and I'm like, oh my gosh, that is crazy how that works. Slide starts with SL. Look at the word translation.
There's SL in the middle of it.
There's an SL in the middle of it. So if you ever forget what the vocabulary term is, and you know you're sliding, there's a hint. Sliding SL translation. Okay, based on Monday's playing with a purpose, some of you realized that if I want to move right, I have to use what kind of number? What kind of number did you have to use?
Positive.
I have to use a positive number. Now, if I want to move right, is that affecting the X or the Y axis?
X.
It is affecting the X axis. I'm going to add that to my flow chart.
X?
It is the X axis. So if I were to redo this flow chart, we've already made it better because if I want to move right, I would use a positive number that affects the X axis and my shape would move to the right.
Wait, how many times can we use these words in here?
I added the word X axis. This is a new word, so this is not in the word bank.
Plus? You said
The plus is in the word bank. It's on the very bottom row. Okay, did you put the plus sign somewhere else?
No, I bet you said X.
Well, if I'm going to move my shape right, I'm going to have to use a positive number on the x-axis. Okay? Now, I added the x-axis part because it's making it a better flow chart. That word was not in the word bank because it doesn't have a shape. Okay? What if I want to move it left?
Negative.
It's going to have to be negative, and which axis is affected? It is still the x-axis. What did you find out if you wanted to move it up?
Positive.
It had to be positive, but now we're dealing with the
Y.
y-axis. And it was probably this piece right here when we wanted to move down, that's where we had our learning on Monday. What kind of number did we have to use to move it down? We had to use a negative. And that was on the, which axis? That was on the y-axis as well. This is a very good marker. It is like almost too much marker. It's like starting to bleed through.
Blue.
It looks blue, but it's purple. Okay, let's go to rotation. This is where I would put most of my time in as far as understanding how this works, because rotations are hard for me. What is the everyday word for rotation?
Turn.
Turn. And when Mrs. McCurdy was telling me this, I'm like, oh, okay, so it works for translation. It works for turn as well. Turn starts with a T. There's a T smack dab in the middle of rotation. Now, when we're dealing with a rotation, it is always around a point. You always have to identify around which point. Now, it can be on the shape. If it's on the shape, like let's say it's on a corner, and I rotate it, what is true about those shapes?
Connected at the corner.
They are connected at the corner. Now, I don't remember which class it was, if it was you guys or if it was another class, but I seriously had someone on Monday put the rotating point in the middle of the side.
On the triangle one that we did earlier, I put the rotation point like on the same point as like the nose thing that you guys were talking about earlier.
Uh-huh.
I put it right there.
You put it on the corner?
I didn't put it on the corner. I put it like the triangle was like this,
Uh-huh.
and I put it like right there.
Oh, so you put it in the middle. But that's...
It wasn't in the middle. It was.
But it's still a point. It's still in the shape. We'll get there. But what happens if I put the rotating point in the middle of a side? What happens to that shape?
It's connected.
It is still connected. So even if it's not at the corner, if you decide to rotate it in the middle of the side, it's still going to be connected to that other shape. Now, what Tanner was saying is if I put it smack dab in the middle, or even if I just put it in the middle of the shape, what happens?
Connect
It's connected, but
on top of itself.
it is on top of itself. It's going to be overlapping. And when it's a square and you rotate it in the middle, that square falls directly on top of itself. And it's kind of hard to see it because it is perfectly on top of itself. This is the tough one for me. I put the rotating point off the shape. When I rotate it, where does it go? It doesn't touch. And that's tough because where does it go? It's not touching. I don't have that reference point, but it still has to be the same distance from that rotating point. That's when I get out that sticky note. Okay. Now, this is the piece that some of you, I know, this is where you struggle, is on reflections. Because when you reflect, you are always reflecting over a line. There has to be a reflecting line somewhere. Okay, first of all, what is the everyday word for reflection? Flip.
FL.
I know. FL, look in the middle of reflection. FL. Crazy. Like, that is just amazing. It worked for all three of them. It doesn't work for dilation.
I know
Dilation's
it's
kind of
dilation.
its own thing. Okay, here we go. This is where some of you had questions. I want to reflect over a vertical line. Now, it's going to give me an equation. The name of that line is always either x equals or y equals some number. If it's a vertical line, how do I know? Is it an x or is it a y?
It's an X.
I've heard x and I've heard y.
If it's going
What
off
about
the
the
X
channel
axis, it'd be X equals a number. But are you talking about the Y axis?
If I'm looking at a vertical line, what is the name of this
Y.
vertical line?
Could be
Y.
both.
If you're saying y, let's look at the y-axis
Y.
here. Is my vertical line going to cross my
No,
y-axis?
because so it'll be X.
Okay, so make sure you're listening here. If I have a vertical line, it runs parallel to the y-axis. Will it ever cross it? No. So when I have a vertical line, that first question that I ask myself is what? What is that first question that I ask myself when I go to name the line? Which axis does it cross? You know what? Let's go ahead and put that down here. Which axis does it cross? If you can't remember whether it's X or Y, ask yourself that question. A vertical line will always cross through which axis?
X.
The X. That's how we know it's going to be X equals.
I thought it was asking like, what is the vertical line?
Yeah, I
first,
know.
too.
Oh, so, okay, just understanding what the question was saying. Now, how do I understand what the number is supposed to be? Where that question mark
Where it's
is?
located on the X axis.
Ah, so where does it cross at? So just two little questions. What axis does it cross? That's going to tell me if it's X or Y. And then where does it cross at? That tells me the number that's going to go where this question mark is. Now let's look at something here. We've got a vertical line. We've got a shape. We reflect the shape over. The shapes are to the blank of each other.
Left and right.
Left and right. If I'm reflecting over a vertical line, they're going to be side by side. They're going to be left and right of each other. Okay, well now understanding that piece is going to help us with the other piece. We already know what my questions are, so this is going to help as well. If I have a horizontal line, is it going to be X equals or Y equals?
Y.
Why? Why is it going to be Y equals?
Because it's going to be going across the Y axis.
It's going to cross the y-axis. And then to fill in the rest of the piece, I would look to see where it crosses the y-axis. For those of you that had questions on the homework assignment, Are you still muddy or are you crystal clear? Did this help make sense?
I don't know. I don't remember. I can't remember how to name
That's exactly what I don't get.
it.
Okay, who can help them how to name it? Because that's just what we went over here. But let's just say it in a different way.
I'll say it in a different way.
Well, okay, let's do this. I don't want to bleed through here. I'm going to just flip this over. Okay. So what we have here is we have the y-axis and we have the x-axis. And let's say we draw this line here. Okay, that's going to be my reflecting line. Their question is, how do you name this line? Now, I don't want to hear from Tanner right now because I know he's got it. I want somebody else to explain to these other guys here, how would I name this line so that they know? Go ahead, Andrew.
You have to say which line crosses, which is the line. And
So you're going to ask yourself, which axis does it cross? And you're going to look and you're going to be like, okay, this line, it crosses the
the line.
y-axis. So that's the first part of the name. And it crosses at the third. So it crosses at 3. That's the name of that line. So which axis does it cross and where does it cross?
So then if it's below, if it's below, then you name it -3. Yeah.
Well, actually, look where I put my line. Is it at -3?
-4.
So that's at -4.
Then how do you do it on the side? Get the side one.
So if I want to go side by side, if I wanted to reflect left and right,
That'd be -2 or +2.
that would be +2. But how? It's not just 2. How would I name it? It's x because this line is now crossing the x-axis and it's crossing it at 2. So that line is x equals 2. So you can put reflecting lines anywhere because now you guys know how to name those lines. So many times we just want to reflect over the y and the x-axis because it's there, it's easy. But now you're like, man, I can remember on that one problem they reflected in the middle, it was like at a half, x equals a half. And they did that so they could get it immediately over to where they needed it to be. So you can put those reflecting lines anywhere. Okay. Oh, we're not done with reflecting yet. If we reflect over a horizontal line, let me just act this out here. The shapes are what?
Above and below.
Above and below. Sorry for making the line so small, but when you type it, it fits. And I had to get all of this onto one page. Okay, tomorrow we're going to work a little bit more on dilations. We're going to see what ends up happening with them. But I think with our ratios and proportions unit, we already have a background in this, so we can fill this out. First of all, a dilation is really what? It is a resizing.
You could remember that by there's 2 eyes and sizing 2.
Yeah, it's just not the same as when it starts with it. So as long as we remember the whole story about, dilating our eyes and our pupils got bigger and contracting our muscles and our muscles got smaller, it's making things bigger or smaller, okay? Now, for some, I don't know what happened here. It's not supposed to say angle S. It's supposed to say angles. Somehow that S got moved to the second line there. If I resize something, if I either blow it up and make it bigger or shrink it and make it smaller, what happens with the angles? They stay the exact same. Because whatever shape it was, it didn't change shape. It didn't become a different shape or a skew or something like that. The angles stayed the exact same. If I took out a protractor and measured them, they'd be the exact same angles. However, can I say that for the side lengths? No. The side length, if I blow it up and make it bigger, what happened to the side lengths?
They got bigger.
They got bigger. If I shrunk it, what happened to the side lengths? They got shorter. But they got bigger and shorter, what would be the word? The sides are all proportional. Did I use the word proportional? Okay. Okay. I would definitely use this flow chart to study from. A great way to study from this is to take this home and explain all of these pieces to your parents. If your parents are too busy, try to get your dog to sit next to you. Mine would look at me with his head cocked to the side and be like, what are you trying to say? And I don't really care if he gets it. I'm caring if I'm understanding this. Because when you have to speak it out loud, you have to think through these processes. So go ahead, and if you don't have a dog, go into the bathroom and tell yourself in the mirror. Teach it to yourself.
My little sibling.
A little sibling. They may not sit very long, but you could try it. Or just pretend. Put a teddy bear right there and tell him. Okay? But if you can say it out loud and understand what you're saying and put a problem with it and make an example, that's even better. Okay,